Negative exponents, Lesson 1.5. Standard is 8EE1. The objective is to simplify expressions involving negative exponents. The essential question is, why is it helpful to write numbers in different ways? Any number raised to the 0 power is 1. 5 to the 0 power equals 1. X to the 0 power equals 1. Anything to the 0 power equals 1. Except 0 to the 0 power does not equal 1. So 0 to the 0 power actually equals 0. Any number to the negative n power is a multiplicative inverse of its nth power. So what that's telling me is that 7 to the negative 3 is written on the wrong side of the fraction. So I'm going to write it over 1, and then I'm going to flip it. 1 becomes my numerator, 7 to the negative 3 becomes my denominator. However, when that 7 to the negative 3 becomes my denominator, I lose the negative. So my exponent is now happy. I'm going to do the same thing for my variable. X to the negative n is going to be written over 1. And then I'm going to go ahead and flip it. My 1 becomes my numerator. My x to the negative n becomes my denominator. I'm going to lose the negative, and then my exponent will be happy. However, this is only true when x does not equal 0. Example 1. Write an expression using a positive exponent. 7 to the negative 2 is going to be written over 1. My negative 2 exponent isn't happy being the numerator, so I'm going to flip it into the denominator. I know that I'm not finished because 7 to the power of 2 gives me 49. So my answer is 1 over 49. Example 2. Write the expression using a positive exponent. B to the negative 4 is going to be written over 1. I know that my negative 4 exponent is not happy being the numerator, so I'm going to go ahead and flip it, and it's going to be 1 over b to the power of 4. Example 3. Write the expression using a positive exponent. M to the negative 3 is going to be written over 1. I know that my negative 3 exponent isn't happy being the numerator, so I'm going to make it the denominator. So I have 1 m to the power of 3. Example 4. Write the expression using a positive exponent. 4 to the power of 0. Anything to the power of 0 will give me 1. Example 5. Write the fraction as an expression using a negative exponent. So right now my exponent is positive. In order to make it negative, I need to move it to the numerator. So my answer would be 8 to the negative 3. Example 6. Write the fraction as an expression using a negative exponent. 1 over 4. I don't see an exponent, but I know that 4 is a squared number, and it can be rewritten as 2 to the power of 2. So now I'm going to move it to my numerator, and then my answer becomes 2 to the negative 2. Example 7. Write the fraction as an expression using a negative exponent. 1c to the power of 5. So all I'm going to do is move it to the numerator, and then I'm going to end up with c to the negative 5. Example 8. A grain of salt has a mass of about 1/10,000 gram. Write the decimal as a power of 10. So if you remember from the last chapter, we learned how to convert a decimal to a fraction. So since I have a 1 in my decimal, that will become my numerator. I'm going to count how many digits are on the right side of the decimal. I have 1, 2, 3, 4. So that means I'm going to have 1, 2, 3, 4 zeros. So it'll be 1 over 10,000. Now I'm going to convert it to a power of 10. So my numerator will still be 1. My denominator will be 10. And then I'm going to count how many zeros I have. I have 1, 2, 3, 4. So it'll be a power of 4. Now I need to make my exponent negative, so I need to move it to the numerator. So my answer will be 10 to the negative 4. Example 9. A water molecule is about this long number meter long. Write the decimal as a power of 10. So since I have a 1 in my decimal, I know that will be my numerator. I'm going to count how many digits are on the right side of the decimal, and that will be my power of 10 for my denominator. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to add my commas. Now I'm going to go ahead and convert it to a power of 10. So I have 1 over 10, and I know I had 10 zeros, so that'll be to the power of 10. Now I'm going to go ahead and make my exponent negative, so I need to move it to the numerator. So it'll be 10 to the power of negative 10. Example 10. Simplify the expression. So I have 3 to the negative 8 times 3 to the power of 2. So all I'm going to do is add and subtract the exponents. So I have negative 8 plus 2. That'll give me 3 to the negative 6. I can also write it as 1 over 3 to the power of 6. It's the same thing, just written differently. Example 11. Simplify the expression. N to the power of 9 times n to the power of negative 4. All I'm going to do is combine my exponents. So 9 take away 4 gives me 5. So my answer is n to the power of 5. Example 12. Simplify the expression. 11 to the power of 2 over 11 to the power of 4. So all I'm going to do is subtract my exponents. So I have 2 minus 4. That gives me negative 2. So that'll give me 11 to the negative 2. Or I can write it as 1 over 11 to the power of 2. I just moved it to the denominator. Example 13. Simplify the expression. I have b to the negative 4 all over b to the negative 7. So since I have negatives on the top and on the bottom, I'm going to go ahead and switch them. I'm going to put b to the negative 4 as my denominator. So I'm going to write b over 4. Now I'm going to go ahead and switch my b to the negative 7 into my numerator. So it'll be b to the 7. Now I'm going to go ahead and subtract. So 7 take away 4 gives me 3. So my answer will be b to the third power.